were unprepared for the sheer volume of lead that P-47s could throw at them. Luftwaffe fighters typically carried 1,000 rounds of 7.92 millimeters ammunition, or 200 rounds of 20 millimeters cannon shells. The P-47 carried 3,400 rounds of .50 caliber ammunition, enough for approximately 30 seconds of sustained fire, or more practically, for 15 to 20 combat bursts. By the time the remaining German fighters broke off the engagement, 2 more FW-190s were falling toward the French countryside, trailing smoke and flame. The P-47s hadn't lost a single aircraft. Back at Lille, the laughter had stopped. The ground crews and pilots who had watched the engagement through binoculars stood in stunned silence. 3 of their squadron mates were gone. The easy targets had proven to be anything but easy. Worse, the Americans had employed tactics that neutralized every German advantage. They hadn't tried to turn. They hadn't tried to climb slowly. They had used speed, altitude, and firepower, American industrial logic, instead of European tactical tradition. A mechanic broke the silence. Those aren't fighters. They're flying battleships. He was more right than he knew. The P-47 represented a fundamental shift in fighter design philosophy. European fighters, British, German, Italian, Japanese, were designed to maximize agility and climb rate within the constraint of available engine power. They sacrificed everything for performance: pilot protection, fuel capacity, ammunition load, even structural strength. A Spitfire MKV weighed 6,650 pounds fully loaded. A Bf-109G weighed 7,055 pounds. These were nimble, deadly aircraft, but they were also fragile. The P-47D weighed 17,500 pounds fully loaded, more than twice the weight of its opponents. But that weight brought capabilities that European designers had considered impossible to combine in a single-engine fighter. The pilot sat behind armor plate and bulletproof glass. The fuel tanks were self-sealing, designed to close automatically when punctured. The oil system had redundant pumps. The control cables were armored. The engine could lose 2 cylinders and keep running. This was American industrial logic made manifest. Build it strong, build it tough, and use overwhelming power to overcome any disadvantages that weight creates. It was the same logic that produced Sherman tanks, Fletcher-class destroyers, and B-17 bombers. It was mass production warfare, where the goal wasn't to build the most elegant weapon but the most effective weapon that could be produced in quantity. And the P-47 could be produced in quantity. Republic Aviation's factories in Farmingdale, New York, and Evansville, Indiana were churning out Thunderbolts at an accelerating rate. By mid-1943, production had reached 500 aircraft per month. By late 1944, it would peak at over 1,000 per month. The Luftwaffe, by contrast, was struggling to maintain production of 1,000 fighters per month across all types, and German fighters were being destroyed faster than they could be replaced. That evening, Oberleutnant Mayatischer's wingman filed a combat report that would be circulated through Luftwaffe fighter units across Europe. Engage new American fighter type, designated P-47. Initial assessment of aircraft as easy target was incorrect. P-47 possesses exceptional diving speed, superior performance above 7,000 meters, and devastating firepower. Squadron leader's aircraft was destroyed in single-firing pass. Recommend immediate tactical revision. Do not pursue P-47s and dive. Do not attempt to outclimb at high altitude. Do not underestimate armament. This aircraft represents serious threat and must be engaged with caution. The transformation had begun. The flying milk bottle was becoming the Luftwaffe's nightmare. The story of the P-47 Thunderbolt begins not with military genius or tactical innovation, but with American industrial ambition colliding head-on with the harsh realities of European air warfare. In 1940, as the Battle of Britain raged across the English Channel, the United States Army Air Corps faced an uncomfortable truth. Every American fighter design was obsolete before it even reached the production line. Alexander de Seversky and Alexander Kartveli, the Russian émigré engineers who had founded Republic Aviation Corporation, originally Seversky Aircraft Company, watched the reports from Europe with growing alarm. The Curtiss P-40 Warhawk, America's frontline fighter, was being outclassed by German Bf-109s and Fw-190s. The Bell P-39 era Cobra, despite its innovative design, was proving disastrously inadequate at high altitudes. Even the vaunted P-38 Lightning, with its twin engines and distinctive twin-boom design, was encountering problems that wouldn't be solved for years. Kartveli, the brilliant Georgian engineer who would become the P-47's primary designer, recognized that American fighter philosophy needed a radical rethinking. European air combat had evolved beyond the dogfighting tactics of World War I. Modern fighters needed to operate at altitudes above 25,000 feet, where American engines struggled. They needed to survive hits from increasingly powerful weapons. Most importantly, they needed to escort heavy bombers deep into enemy territory, a mission profile that didn't yet exist in American tactical doctrine, but was becoming inevitable as the U.S. moved toward war. In the summer of 1940, Kartveli locked himself in his design office with a set of requirements that seemed mutually contradictory. The Army Air Corps wanted a fighter with 8 heavy machine guns, armor protection for the pilot, self-sealing fuel tanks, high-altitude performance, and the ability to escort bombers hundreds of miles into enemy territory. Each of these requirements added weight, and weight was the enemy of fighter performance. The solution Kartveli proposed was heretical. Instead of trying to minimize weight, he would embrace it. He would build the largest, heaviest single-engine fighter ever conceived and power it with the most massive engine available, the Pratt & Whitney R-2800 Double Wasp, an 18-cylinder radial engine that produced 2,000 horsepower. The R-2800 was itself an engineering marvel. 18 cylinders arranged in 2 rows of 9, each cylinder displacing 2,804 cubic inches, hence the designation R-2800. The engine weighed 2,360 pounds dry, as much as an entire Fiat CR.42 biplane fighter. It was 4 feet in diameter and required a massive cowling that dominated the P-47's nose section, but raw power was enough. The R-2800, like all aircraft engines of the era, lost power as altitude increased and air became thinner. At sea level, the R-2800 produced 2,000 horsepower. At 25,000 feet without assistance, it would produce less than 800 horsepower, insufficient for combat performance. To overcome this limitation, Kartveli designed the P-47 around a massive General Electric turbo-supercharger. Exhaust gases had to travel from the engine, mounted in the nose, to the turbo-supercharger, mounted in the rear fuselage, through pipes that could withstand extreme temperatures without warping or cracking. Compressed air from the turbo had to return to the engine through intercoolers that reduce its temperature. Hot compressed air is less dense than cool compressed air. The pilot needed controls to regulate the system, preventing overboost that could destroy the engine or underboost that would sacrifice performance. When Kartveli presented his preliminary design to the Army Air Corps in September 1940, the reaction was mixed. The aircraft would weigh over 12,000 pounds fully loaded, nearly twice the weight of a Spitfire. It would be powered by the largest engine ever fitted to a single-seat fighter. It would carry 8.50 caliber M2 Browning machine guns with 425 rounds per gun, a total of 3,400 rounds of ammunition that alone weighed over 2,000 pounds. "It's too big," one Army officer protested. "It'll never be able to turn with a Messerschmitt." Kartveli's response was prophetic. It doesn't need to turn with a Messerschmitt. It needs to catch a Messerschmitt, destroy it, and survive to do it again tomorrow. The armament system deserves special attention because it represented the P-47's most distinctive capability. The 8.50 caliber Browning M2 machine guns were positioned in the wings, for guns per wing, staggered to allow their ammunition boxes to fit within the wing's internal structure. Each gun was fed by a booster mechanism that ensured reliable feeding even during violent maneuvers and high G-forces. The decision to use .50 caliber machine guns rather than 20mm cannons was controversial. European fighters increasingly relied on cannons, which fire heavier shells with greater destructive power per hit. A single 20mm shell could destroy an engine or blow off a wing. But cannons had significant disadvantages. They fired more slowly, typically 400 to 600 rounds per minute versus 800 rounds per minute for the .50 caliber. Carried less ammunition. German fighters typically carried 200 cannon rounds versus the P-47's 3,400 rounds of .50 caliber, and required more precise aiming. Kartvel's choice of the .50 caliber Browning was based on American tactical thinking. Spray a large volume of fire rather than relying on precisely placed shots. 8 guns firing simultaneously created a cone of destruction that didn't require pinpoint accuracy. A pilot who aimed in the general direction of an enemy aircraft would score hits. Those hits, while individually less destructive than cannon shells, were collectively devastating. The .50 caliber armor-piercing incendiary, API, round was particularly effective. The projectile had a hardened steel core that could penetrate light armor, backed by an incendiary compound that ignited on impact. Against aircraft, these rounds punched through aluminum skin, shattered structural members, severed control cables, punctured fuel tanks, and ignited fuel or hydraulic fluid. The cumulative effect of multiple hits was catastrophic. On September 6, 1940, the Army Air Corps signed a contract for 171 production aircraft plus 1 prototype to be designated XP-47B. It was an unprecedented vote of confidence in an improving design and a gamble that American military and industrial leaders were willing to take as war clouds gathered. The first challenge was simply fitting everything into the airframe. The R-2800 engine alone was nearly 4 feet in diameter. The turbo-supercharged system required ducting that snaked through the fuselage. The 8 machine guns needed to be positioned in the wings with adequate ammunition supply. The pilot needed armor protection and a bubble canopy for visibility. Self-sealing fuel tanks, radios, oxygen systems, and control mechanisms all competed for space. Kartvel's solution was to make the fuselage wider and deeper than any previous fighter. The P-47's fuselage at its widest point measured 4 feet 8 inches, wide enough that some pilots joked they could walk around inside it. This width, combined with the aircraft's length of 36 feet, gave it a massive frontal area that should have created enormous drag. But Republic's engineers were clever. They carefully shaped the cowling and fuselage to create smooth airflow, and they positioned the turbo-supercharger in the rear fuselage, where it could use exhaust gases efficiently without disrupting the aircraft's aerodynamics. The resulting design was undeniably bulky, but it was also surprisingly clean from an aerodynamic standpoint. In wind tunnel tests, the P-47's drag coefficient was actually lower than the FW-190's, despite being significantly larger. The landing gear presented another engineering challenge. The P-47's weight required exceptionally strong main gear, but the wings were already packed with guns, ammunition, and fuel tanks. Kartvel's solution was ingenious. He designed a telescoping landing gear that retracted inward and upward, shortening as it folded into the wing. When extended, the main gear was over 9 feet long, taller than many pilots. When retracted, it fit neatly into wells that were only about 4 feet deep. This telescoping mechanism added complexity and weight, but it was the only way to provide adequate ground clearance for the massive propeller while keeping the wing thin enough for good aerodynamic performance. The prototype XP-47B first flew on May 6, 1941, 8 months after the contract was signed and 7 months before Pearl Harbor brought America into the war. Test pilot Lowry Brabham lifted the massive fighter off the runway at Farmingdale and immediately encountered a problem. The canopy latch failed, and the canopy flew off at 100 feet. Brabham, showing the steady nerves that test pilots must possess, continued the flight and landed safely despite wind blasts that made communication impossible and created severe buffeting. Once the canopy problem was fixed, the XP-47B began to demonstrate its potential. In level flight at 25,000 feet, it reached 412 miles per hour, faster than any American fighter then in service. Its climb rate, while not exceptional, was adequate. The aircraft could reach 15,000 feet in approximately 8 minutes. Most impressively, it maintained its performance at altitudes where other fighters were struggling. At 30,000 feet, where a Spitfire MKV could barely reach 350 miles per hour, the P-47 could still hit 400 miles per hour. The turbo-supercharger was performing exactly as Kartveli had predicted. At high altitude, with thin air robbed normally aspirated engines of power, the P-47's turbocharged R 2800 maintained consistent output. This gave the Thunderbolt a decisive advantage in the high-altitude combat that would characterize much of the air war over Europe. Transitioning from a successful prototype to mass production proved extraordinarily challenging. Republic Aviation had never manufactured aircraft in large quantities, and the P-47 was one of the most complex fighters ever designed. Each aircraft contained over 1,400 major components and thousands of smaller parts. The assembly process required approximately 150,000 man-hours per aircraft, compared to roughly 10,000 man-hours for a Bf-109. The turbo-supercharger system alone required precision manufacturing that pushed the limits of 1940s industrial capability. The Army Air Forces, renamed from Army Air Corps in June 1941, initially ordered 602 P-47BS in March 1942, but Republic struggled to deliver.